In this next example, we're going to look at real and imaginary parts of a function. So we know that the right-hand guy is going to be a complex number no matter what z we plug in. So what we want to know is in terms of x and y, sort of what if we were to plug in a random one x plus iy, what terms don't have an I and what terms do have an I. So what is the corresponding real expression and imaginary expression for this guy? So how do we do it? Well, we just plug in, like I said, an x plus iy and we see what happens. So we have x plus iy squared minus 2i times x plus iy. All right, let's square this out. So x squared plus 2ixy, or let's write it like this, 2xyi minus 2x, all right, let's put brackets so we don't mess up negatives, plus 2yi plus xi plus yi squared, I think. So that's x squared plus 2xyi minus, that's a negative y, so we're going to have a 2x minus y here, and then 2y plus x on the I. Great. And now let's subtract off the real parts of these. So we're going to get x squared minus 2x minus y, and then plus 2xy minus 2y plus x. I, that's the imaginary part. And so we're going to get, it looks like x squared minus 2x, if we multiply that negative in, plus y. I'll associate them. And then we'll multiply that negative in, so we'll get 2xy minus 2y plus x, or minus x. Oops, almost made a blunder. All right, so if we plug in a random complex number, something of the form x plus iy, we can sort of collect the terms that don't have an I and collect the terms that do have an I, just like in the last chapter. And so the real part of f is x squared minus 2x plus y. And the imaginary part of f is 2xy minus 2y minus x. And later, we'll give these a special variable that we'll always use for the real part. So let's do that now to mimic the example in the book. So in the book, we'll usually use u for the real part, and then v for the imaginary part. And u and v are both functions of x and y. So I'm just being clear what they're a function of here. So that's one example. This is the real and imaginary part of our f from the last one. Let's do g from the last video. So our g, if you recall, is z plus twice the real part of z. Okay, so what we want to know is what's the real and imaginary part. So how do we do that? Well, we break our z up as a real and imaginary part, and then we compute and simplify as much as we can on the right-hand side and see what we get. So we have x plus iy plus twice the real part of x plus iy, that's just twice x. And then we combine them. So it looks like we get 3x's plus iy. So the real part of g, which I'm going to denote as u, is 3x. And the imaginary part of g, which I'm going to denote as v, is y. Let's just label them. This is the real part of g as a function of x and y, and the imaginary part of g as a function of x and y.